In 1809, a boy was born inside a one-room log cabin in Hodgenville, Kentucky. The floor was packed dirt. The walls were rough-hewn logs stacked and notched at the corners. The gaps between them were stuffed with mud and dried grass to keep out the wind. There was one door, one window covered with greased paper, and a stone fireplace that barely kept the frost off the walls in January. That boy was Abraham Lincoln, and the cabin he was born in was built the same way settlers and mountain men had been building across the American frontier for more than 150 years before him, with an axe, a knife, and whatever timber the land gave them. That was 1809. By 1860, Lincoln was president, running a country from a mansion in Washington. By 2026, that original Kentucky cabin is long gone, but log structures built the same way, some of them older by 2 centuries, are still standing across the eastern United States and northern Europe. Meanwhile, houses built in the 1980s are already getting torn down. So how did people with no power tools, no hardware stores, and no engineering degrees build structures that have outlasted almost everything we put up today? 100 years before Lincoln's birth, the American frontier was a wall of forest stretching from the Appalachian ridgelines to the Mississippi River and beyond. Settlers pushing west through Virginia, the Carolinas, Kentucky, and Tennessee needed shelter fast. They couldn't haul lumber across mountain passes on horseback. They couldn't carry bags of nails on a flatboat down the Ohio River. Even if they could, hand-forged nails cost more than most families could afford. What they had was trees, millions of them. White oak, American chestnut, poplar, spruce, and pine, growing thick from valley floor to ridgeline. And they had knowledge passed down from European immigrants who had been building with logs for centuries before anyone set foot in the New World. The techniques didn't start in America. They started in Scandinavia and Northern Europe, where Finnish, Swedish, and German builders had perfected horizontal log construction going back to the Bronze Age, roughly 3,500 years before Christ. In the dense coniferous forests of Finland and Sweden, where straight pine and spruce trees grew tall and thick, builders developed a system of stacking horizontal logs and interlocking them at the corners using nothing but an axe, a knife, and a log scriber. They used no nails, no pegs, and no metal of any kind, just the precision of the cut. When Swedish and Finnish colonists settled along the Delaware River in 1638, establishing the colony of New Sweden in what is now parts of Delaware, New Jersey, Pennsylvania, and Maryland, they brought those skills with them. The Scots-Irish had no log-building tradition of their own, but they picked it up fast. So did the English. So did German settlers pushing into Pennsylvania Dutch country and the Shenandoah Valley. Within a generation, log construction had become the default building method across the entire American frontier. And from the 1710s onward, as waves of settlers pushed south through the Appalachian valleys and west across the mountain barriers into Kentucky, Tennessee, and the Ohio River Valley, every new homestead started the same way. Find a clearing, fell the trees, build a cabin. What those early builders understood was something that would take modern engineers centuries to put into equations. They understood wood, not in the way a lumber yard understands wood, as a commodity measured in board feet. They understood it the way a surgeon understands a body. They knew which species resisted rot and which ones invited it. They knew that oak and chestnut could take a century of weather and barely flinch, while softer species needed more protection. They knew to fell trees in late autumn or winter when the sap was down because green wood warped and cracked as it dried. And they knew to strip the bark immediately because bark trapped moisture against the heartwood and invited the kind of decay that could bring a wall down in a decade. This is where the story takes a turn nobody expected. Because the real genius of these cabins wasn't the logs themselves, it was how the builders locked them together. The corner notch is what separates a log cabin from a pile of timber. And on the American frontier, there were several ways to cut one. The simplest was the saddle notch, a rounded scoop carved into the bottom of each log so it seated down over the log beneath it. A saddle notch was fast. A skilled man with a sharp axe could cut one in minutes. For a temporary hunting shelter or a first-season homestead, it worked fine. 3 men once set a record by felling trees, trimming them, dragging the logs to a site, notching every one, and building a complete one-room cabin with a chimney and fireplace in 2 days. That's not a typo, by the way. 2 days. No power tools, no crane, no concrete truck, just axes and sweat and a knowledge of wood that most modern carpenters would struggle to match. But the saddle notch had limits. It left the log ends exposed to rain, and over time, water could wick into the end grain and start the slow rot that eventually loosened the joint. For a cabin meant to last a lifetime, or longer, mountain builders turned to something more precise. The dovetail notch changed everything. If you've ever seen a dovetail joint in a piece of fine furniture, you know the shape. A flared, trapezoidal cut that locks 2 pieces together so tightly that pulling them apart is nearly impossible. Now imagine that same joint, but carved into logs that weigh hundreds of pounds each. The dovetail was harder to cut. It demanded more skill, sharper tools, and a better eye for angles. But once stacked, the interlocking joints created a structure with serious load-bearing strength. The weight of each successive log actually pressed the joint tighter. Gravity wasn't fighting the cabin. Gravity was holding it together. And because the dovetail tapered inward, it channeled water away from the vulnerable end grain. Rain hit the joint and slid off instead of soaking in. The same joint that kept the cabin standing also kept it dry. The V-notch was another variation, characteristic of Pennsylvania German building traditions, where each log was hewn with an inverted V on one edge and a matching groove on the other. When stacked, the V locked into the groove and created a tight, self-draining seal. Different regions favored different notches, but every style shared the same principle. The cabin held itself together through geometry, not fasteners. Not a single nail, screw, or metal bracket anywhere in the structure. Just the precise relationship between one piece of wood and the next. Now, cutting a dovetail notch into a 300-pound oak log with nothing but hand tools is exactly as difficult as it sounds. And it starts with the tools themselves. The felling axe brought the tree down. A good one weighed around 4 pounds, with a high carbon steel head on a hickory handle, and a mountain man kept the edge sharp enough to shave with. After felling, the log had to be shaped. This is where the broadaxe came in. The broadaxe was a specialized tool, heavier than a standard axe, with the blade ground on only one side, so the flat face could ride along the surface of the log while the beveled edge bit into the wood. A builder would first score the log at regular intervals with a standard axe, chopping straight down into the round surface every 8 to 10 inches. Then he'd come back with the broadaxe and hew off the chunks between the score marks, leaving a rough but approximately flat face. The finished timber was more rectangular than square, and the surface carried the distinctive angled tool marks that you can still see on cabins standing today. The adze did the finer work. It looked something like a garden hoe, with a curved blade set perpendicular to the handle. Standing on top of the log, a builder would swing the adze between his legs in a controlled arc, shaving the surface smooth. The draw knife handled the detail work, pulling long curls of wood to create the precise angles needed for a tight notch. And the froe, a heavy blade struck with a wooden mallet, split logs into the thin boards used for roofing shingles and floor puncheons. That was it. An axe, a broadaxe, an adze, a draw knife, a froe, and a knife. With those 6 tools, a man could build a house. No trip to a hardware store, no delivery truck, no extension cord. Just sharp steel and the skill to use it. And a mountain man kept every edge razor sharp because a dull tool was more dangerous than a sharp one. A dull axe bounced off the wood. A sharp one bit clean and went exactly where you aimed it. The quality of these tools mattered enormously. High-carbon steel heads were forged by blacksmiths, sometimes carried hundreds of miles across the frontier because a good axe head was worth its weight in trade goods. The handles were almost always hickory, chosen for its combination of strength and shock absorption. A bad handle could snap mid-swing and send the head flying. A good one would last years of daily use before needing replacement. The cabin itself started from the ground up, literally. The builder chose a site with natural drainage, because standing water was the enemy of any wooden structure. Cornerstones, usually large flat rocks pulled from a nearby creek bed, were set level at each corner to lift the first logs off the damp earth. This was critical. A log sitting directly on soil would wick moisture from the ground and begin rotting from the bottom within a few years. The stone foundation broke that contact and let air circulate beneath the structure. With the cornerstones set, the first two sill logs went down, running parallel on opposite sides. These sill logs were critical. They bore the weight of the entire structure, so builders picked the densest, most rot-resistant timber they could find, often white oak or American chestnut. Then 2 more logs crossed on top at each end, notched, to seat down snugly. And from there, the walls rose 1 course at a time. Each log notched and seated, the wall climbing toward the roofline with every course. Most early cabins were a single room, or what builders called a pen, measuring somewhere around 12 to 16 feet square. That's small by modern standards. But it was enough to shelter a family through a frontier winter, and more importantly, it was a size that 1 or 2 men could build without needing to lift logs that were impossibly heavy. As the walls rose higher, builders used ramps made from smaller logs to roll the upper courses into position. Some used a system of forked poles as crude levers. There was no winch, no pulley, no mechanical advantage beyond what a man could rig from the materials at hand. The roof came last, usually built from split logs or hand-riven shingles laid over a ridgepole. A froe and a mallet could split a straight-grained log into dozens of thin, overlapping shingles that shed water effectively for decades. Some builders cut a hole in the roof for a chimney. Others built a full stone fireplace against one wall, with a chimney stack made from stacked fieldstone and clay mortar. The decision about where to place the cabin and how to lift it off the ground seemed small at the time. It wasn't. It's the reason some of these cabins are still standing, and others turned to mulch within a generation. A cabin built in a low-lying area where water pooled after rain was a cabin on a countdown. A cabin placed on high ground with good drainage and a solid stone foundation could stand indefinitely. Between the logs, gaps remained. Even the best-fitted walls left spaces where wind and rain could push through. This is where chinking and daubing came in, and the materials varied depending on what the land offered. In the Appalachian Highlands, builders often packed the gaps with thin wood strips or stone chips first, then sealed everything over with a thick paste made from local clay mixed with water, sand, and sometimes animal hair for binding strength. In other regions, moss served as the primary filler, pressed between the logs while still damp so it would expand as it dried and create a tighter seal. The chinking wasn't just weather protection, it was insulation. And here's where these cabins start to outperform what you might expect from a pile of logs and mud. The U.S. Department of Energy has studied the thermal performance of log walls, and what they found surprised a lot of people. A solid log wall has an R value, that's the measure of resistance to heat flow, of roughly 1.41 per inch for softwoods. So a 6-inch pine wall gives you an R value just over 8. Compare that to a modern stud wall packed with fiberglass insulation at about R14, and the logs look weak on paper. But R value only measures one thing: conduction. It doesn't account for thermal mass, which is the ability of a material to absorb heat, store it, and release it slowly over time. And this is where logs become something the Department of Energy actually calls thermal batteries. During the day, sunlight warms the exterior of the log wall. That heat migrates slowly through the wood's mass, reaching the interior hours later, often right around evening when the temperature outside drops and you actually want that warmth. At night, the process reverses. The logs radiate stored heat back into the cabin while the outside air cools. The net effect is that a log cabin's interior temperature stays more stable than the raw R value would predict. The Department of Energy has noted that thermal mass can effectively add an estimated 0.1 per inch to a log wall's apparent R value in climates with significant day-to-night temperature swings. And in the mountains, where a summer day might hit 80 degrees and a summer night drops into the 40s, that thermal mass effect was the difference between comfort and misery. Mountain men didn't have thermometers or R value charts. They didn't need them. They knew from lived experience that a properly built log cabin with tight chinking stayed warm through a mountain winter in a way that a drafty plank structure never could. The science just hadn't caught up to what they already understood. If you're finding this useful, hit subscribe. I cover stories like this every week. By the 1840s, the Oregon Trail migrations were in full swing, and somewhere between 300,000 and 400,000 settlers crossed 2,000 miles of prairie, desert, and mountain to reach the Pacific Northwest. When they arrived in the timbered valleys of Oregon and Washington, after months of walking beside an ox cart, the first thing most of them built was a log cabin. Not a tent, not a lean-to. A permanent structure with 4 walls, a roof, and a fireplace. The same techniques that had worked in the Appalachians 200 years earlier worked in the Cascades and the Rockies. The tools were the same. The notches were the same. The logic of the building was the same. Out in the Rocky Mountains, the cabin design evolved slightly to handle heavier snowfall. Builders started placing the entrance in the gable end instead of under the eaves, and some added a small porch supported by corner posts created from an extension of the roofline, which kept heavy roof slides from burying the front door in winter. But something was changing. By the middle of the 19th century, sawmills had begun to spread across the country. Suddenly, instead of spending days hewing a log flat with a broadaxe, a builder could have it sawn into precise boards in hours. The introduction of machine-cut nails, and later wire nails, made fasteners cheap and abundant for the first time. Balloon framing, the stick-built construction method that still dominates residential building today, emerged in the 1830s in Chicago. It used thin, standardized lumber pieces nailed together in a framework, and it was fast, cheap, and required far less skill than traditional log construction. The frontier cabin didn't disappear overnight, but the knowledge behind it began to fade. When you can buy pre-cut lumber and a keg of nails, there's no reason to spend 3 days hewing logs with a broadaxe. When a sawmill can produce boards by the thousands, the incentive to master dovetail joinery vanishes. Within 2 generations, the hand tool mastery that had built the American frontier was a curiosity, not a trade. You'd think someone would have said something. Nobody did. The skills just quietly died out as the people who held them got old and the young ones moved to towns where dimensional lumber came off a truck. And that brings us to the uncomfortable comparison. The average modern stick-built home in America, the kind framed with 2x4s and sheathed in plywood and wrapped in Tyvek and sided with vinyl, has a projected lifespan of roughly 70 to 100 years. That's according to standard residential building estimates. Some last longer with aggressive maintenance. Some start showing serious problems within 40 or 50 years when the roof fails or moisture gets behind the siding or the foundation settles and the framing racks. Now, compare that to what mountain men were building with an axe and a pile of trees. The Nothnagel cabin in Gibbstown, New Jersey, was built by Finnish settlers around 1638. It's constructed from white oak logs joined with dovetail notches, built without nails or modern fasteners of any kind. Experts declared it the oldest log cabin standing in its original location in the Western Hemisphere. It was added to the Library of Congress in 1922 and the National Register of Historic Places in 1976. The cabin has retained all but one of its original logs. That's nearly 400 years of standing with the same wood that was cut from the forest when the colony of New Sweden was still a going concern. In Sweden, the evidence is even more dramatic. The Granhult Church in Småland province dates to the 1220s. That's 800 years old. In the Dalarna region alone, researchers using dendrochronology, which is the science of dating wood by analyzing its growth rings, have dated more than 150 timber buildings to the period between the 1200s and the 1500s. Many of them are still in use, not preserved behind glass in a museum. In use. People walk through them, store grain in them, worship in them. The tithe barn at Ingetorp, built around 1230 as a tax storehouse for the local church, still stands in nearly its original condition. Its walls are log construction covered in red-painted wooden shingles, and some of those shingles date back to the 1500s. The roof was replaced with tiles in the 19th century, but restored to wooden shingles in 2017 to match the original design. A cabin restored in the modern era, originally built in 1857, needed only 5 of its original logs replaced during the full restoration. Everything else, the notches, the framing, the structural timbers, was still sound after more than 160 years. The kind of number that makes engineers do a double take. So what happened? How did we go from building structures that last 8 centuries to building houses that struggle to make it past one? Part of the answer is economics. Modern construction is optimized for speed and cost, not for permanence. A developer building a subdivision doesn't need each house to last 500 years. They need it to last long enough to sell, pass inspection, and not generate lawsuits within the warranty period. The incentive structure points toward fast, cheap, and code-compliant, not toward the kind of craftsmanship that a Finnish settler brought to a dovetail notch in 1638. Part of it is materials. Dimensional lumber from a modern sawmill is a fundamentally different product from a hand-selected, hand-hewn log. Modern framing lumber is often cut from fast-growth plantation trees, dried in a kiln, and graded for minimum structural requirements. It works fine for its purpose, but it doesn't have the density, the grain structure, or the rot resistance of a slow-growth hardwood that spent a century adding rings in an Appalachian forest before someone brought it down with a felling axe. And part of it is knowledge. The apprenticeship traditions that once passed log-building skills from one generation to the next have largely broken. A frontier boy grew up watching his father and his neighbors build. He learned to read wood grain the way a modern kid learns to read a screen. By the time he was old enough to build his own cabin, he had years of hands-on experience with every tool and every technique. That chain of knowledge, passed shoulder to shoulder across generations, is what made the craftsmanship possible in the first place. A modern carpenter trains with nail guns and circular saws and laser levels. These are excellent tools, but they're tools designed for a completely different building system. Ask a modern framing crew to hew a log flat with a broad axe, cut a dovetail notch by hand, and stack a self-supporting wall without a single fastener, and most of them would be starting from scratch. Not because they're less skilled, because they were trained in a tradition that doesn't require those skills anymore. And building codes, designed around manufactured materials like dimensional lumber and engineered panels, don't make it easy to build the old way even if you want to. Log structures often fall outside standard insulation requirements because the R-value calculation doesn't account for thermal mass. A builder who wants to construct a traditional log cabin today may have to file for alternative compliance under the International Energy Conservation Code just to get a permit. The system is designed for the way we build now, not the way we used to. There are people keeping these skills alive. Small communities of traditional log builders, timber framers, and historical preservationists still practice the old methods. Organizations like the American Log Builders Association and craftspeople working in the Scandinavian tradition continue to build by hand. But they're a tiny fraction of the construction industry, and the gap between what they know and what mainstream builders know grows wider every year. The cabins that mountain men left behind on ridgelines and in river valleys across the American frontier were never meant to be monuments. They were shelter. Practical, urgent, built from necessity with whatever the forest offered. The men who cut those dovetail notches and packed those chinking seams weren't trying to build something that would last 400 years. They were trying to survive the winter. But the way they built, the material choices, the joinery, the respect for how wood moves and breathes and responds to its environment produced something that modern construction, with all its technology and engineered materials, has yet to match in raw durability. A log cabin doesn't fight nature. It works with it. The wood expands and contracts with the seasons. The thermal mass breathes with the temperature. The joints tighten under their own weight. Everything in the system cooperates instead of resisting. Modern construction fights nature with synthetic barriers, chemical treatments, and manufactured seals that break down over decades and need constant replacement. A frontier cabin cooperated with nature and asked for nothing but occasional rechinking in return. Walk into any log cabin that's been standing since the 1700s, and you'll see the broadaxe marks still visible on the timbers. You'll see the dovetail joints fitted so tightly that a knife blade won't slide between them. You'll feel the walls radiate warmth in winter, absorbing and releasing heat the way they've done every day for 200 or 300 years. What survived isn't just the wood. It's the proof that an axe, a pile of trees, and a man who understood both of them could build something that outlasts everything we've built to replace it.